This is our chemistry presentation, and here's something cool.
1 minute, 37 seconds later.
Who got lemon on my floor? Whatever will I do?
Don't worry about it, I can fix it.
But how?
I'll show you how. When a solute is dissolved in a solvent, it can break down and form either hydrogen ions or hydroxide ions.
Acids are solutions with excess hydrogen ions. Bases are solutions that have excess hydroxide ions which accept hydrogen ions. As you can see here, we have it set up from the most acidic substance to the most basic substance. We will be using pH tabs to show how they change from one to the other.
Using this color-changing paper on a substance will give you 1 through 14 numbers on the pH scale, with number 1 being the most acidic and number 14 being the most basic.
Strong acids tend to be below 4, while strong bases tend to be above 10. However, there are weak acids and bases which tend to be around 5 to 9. Neutral, mainly just water, is a 7.
Neutralization is the process of combining an acid and a base to form water and salt. When an acid gives off its hydrogen ions to a base, that acid will turn into a conjugate base. When the base accepts that hydrogen ion, it will turn into a conjugate acid.
Neutralization allows you to clean things, such as acidic lemon juice with a basic cleaner. But other things can be kept at certain pH levels to achieve certain results. Here's a couple of examples.
Pools must be kept at a 7.2 to 7.5 pH level. If it is too acidic, it will cause corrosion. If the pH level is too basic, it will cause calcium scales to form in the pool and causing the water to turn murky.
Acids and bases can also play into hair care. For example, the cuticle layer inside your head holds onto every single strand of hair. As hair gets more basic, it will expand and open up and allow you to deposit pigments into it. This will allow you to dye your hair. Now, applying acid to your hair will contract it and allow it to hold on to these pigments. However, it is only recommended to use weak acids and bases for this process because strong acids and bases can make your hair damaged. Titration is the process of finding the unknown concentration of a substance by mixing it with another substance. In this next example, we are going to use an acid, well, hydrochloric acid to be precise, and sodium hydroxide, and we will indicate the change with phenolphthalein. Well, for titration, we need the molarity of the acid times the volume of the acid, and that's going to be equal to the molarity of the base times the volume of the base. Now, we know that I measured out 25 milliliters of hydrochloric acid, and we know that 12 milliliters of sodium hydroxide were displaced from the burette. Now, if that sodium hydroxide was 1 molarity, then that just means we need to solve for the molarity of the acid. Okay, so that means 12 on the base side is equal to 25x on the acid side. Now, if we just divide that, that means x is going to be equal to 0.48 molarity. So, basically, that's it for our presentation on acids and bases. As you can see, they have many uses in our real lives as well as many other applications. Now, if you'll excuse me, I gotta go clean that lemon off the floor.